Hi all. Yesterday we discussed about the coal gasification and the coal liquefaction. Today we are going to discuss about the difference among the different nature of fuels and liquid nature of fuels. Coming to the difference among the different natures of fuel, crude oil is the oil which is pumped out of the ground, and this crude oil is also known as a black liquid. The constituents of this liquid are aliphatic hydrocarbons or the hydrocarbons. Hydrocarbons are nothing but it composed of hydrogen and the carbon, wherein the carbon atoms link together in the chains of varying length. Suppose C, C2, C3, C4, which we can say that carbon atoms link together in the chains of varying length like C2, C4, C5 in similar way. What are actually different lengths of hydrocarbons have the different properties and the behavior. For an instant, one carbon atom chain is a lightest chain. Example CH4, which we'll call as a methane. This is the lightest chain because it contains only one carbon. So, longer the chain, heavier is the hydrocarbons. The first four chains of hydrocarbons, such as CH4, which is methane, C2H6, ethane, C3H8, propane, and C4H10, butane. All these four are gases, and the chains up to C18H32 are liquids, as well as the chains above C19 are solids at room temperature. Coming to the liquid nature of fuel, before going to that, first we have to know about the distillation. What actually the distillation mean? As we said, crude oil contains a variety of hydrocarbons. These have different boiling points. In order to separate these compounds, the oil is first sent into a boiler where is heated into a super hot mixture of liquid and the vapor called as the feed. Next, the mixture is then fed into a distillation tower. Here, the compounds with lower boiling point rises up as the vapors, while the compounds with higher boiling points fall down as a liquid. Here we can see that this is the distill tower. From here, based on their boiling points, we will get this petrochemical outputs. So what is this? Actually, we can call this as a fractional distillation because the distillated products are then piped off from the different levels of tower. These separated products are called as the fractions or the distillates. Okay, coming to the liquid nature of the fuel, petroleum. Actually, petroleum often referred to as a crude oil. It is naturally occurring liquid found in the geological formation beneath the earth's surface. As we said, crude oil or a petroleum is composed of primarily of an hydrocarbons, and this crude oil is a key source in the global energy sector. Then what are the products and the uses of this? Due to this fractional distillation, it produces, like, based on their boiling point, it produces a gasoline, diesel, kerosene and the jet fuel. What are the products and the uses? As I said, it produces fuels like gasoline, diesel, jet fuel and the heating oil are the primary fuels derived from the petroleum and are used in the transportation, power generation and heating. And how these petrochemicals use this, petrochemical industries use it. Petrochemical industries use petroleum as a feedstock to produce a wide range of products including plastic, fertilizers, synthetic fibers and the chemicals. And how are these are useful in the form of lubricants and the waxes? These are essential for machineries and the vehicle engines, while petroleum based waxes are used in the packing, candles and the cosmetic. Coming to the second type of fuel, gasol. Actually, it's firstly discovered in Brazil. It is a mixture of 80 to 90% of petrol and the 10% of alcohol. It is obtained by mixing petrol in extracted alcohol of the sugarcane. Actually, we can extract the alcohol out of the sugarcane by mixing petrol 80% to 90% of the petrol and the 10% of the alcohol. We get this gasol. By use of this gasohol as a fuel in the vehicle, pollutant like CO2, carbon dioxide, SO2 can be reduced and minimized up to the extremely lower levels. In such a way, gasohol can be better alternative options of the petrol because of the great demand of petrol. Coming to third one, diesel. Actually, this is a type of oily liquid hydrocarbon obtained from the fractional distillation of the petroleum. This is cheaper than the petrol and a good fuel used in vehicles, missions, devices, etc. But during its consumption, various toxic gases like sulfur dioxide are evolved. The gases sulfur dioxide creates some problem like irritation in the eye, headache, inhaling problems, and sometimes skin diseases and the respiratory system problems also come into the existence. Coming to the fourth type, ultra low sulfur diesel or the city diesel. This is extremely the pure form of the diesel. Though the combustion of this diesel through the combustion of this diesel, less pollutants are spread in the atmosphere because of low sulfur presence in it. So it can be used as frequently in almost all cities of Europe. So it is also called as a city diesel. Coming to what is asphalt and bioasphalt. Coming to what is asphalt and the bioasphalt. Asphalt is highly viscous hydrocarbon produced in the residue of the petroleum distillation. And bioasphalt is an alternative of the asphalt made from the non-petroleum based renewable sources. These sources include sugar, molasses, rice, corn, potato, starch, gum, resins, latex, vegetable oil, cellulose, etc. Actually, bioasphalt is eco-friendly and is also used in the road construction. Uh, so, asphalt is in brown or black in color. So, coming to the what is the research octane number? What actually mean it? Actually, research octane number is a standard measure of the performance of the gasoline engine fuel. In order to check the performance of the gasoline engine fuel, we based on the research octane number only we are able to find it the performance of the gasoline engine fuel. Then what, how we can say that whether the higher RON is better or lower RON is better. RON is nothing but a research octane number. Fuel with higher research octane number are mostly used in the higher performance engine. Actually, higher performance engines have an higher compression rate. Then what is the compression rate? It is simply the ratio of volume inside the cylinder of the engine before and after the compression. Means before the compression, how much the volume present inside the engine, and after the compression how much the volume present in a engine. So it is nothing but a ratio of volume inside the cylinder of engine before and after the compression. This is nothing but a compression ratio. As I told, fuels with higher research octane numbers are mostly used in higher performance engine, and in turns higher performance engines have a higher compression ratio. So, and the other thing we have to know here is knocking or pinging sound. What actually is the knocking and the pinging sound? Knocking in normal petroleum engine, the air fuel mixture is heated due to being compressed. After compression, then is ignited rapidly by the spark plug. If this mixture is heated too much or too compressed, we can say too much is like it is being more compressed, it will self ignite before the ignition system sparks. This will lead to much higher stress than what the engine components are designed for and causes a knocking or pinging sound. Did you get it? Like if it has been self ignited before the ignition system spark, then it leads to high stresses what actually the engine components are designed for. So then it causes the knocking or pinging. What actually is the knocking and pinging? Some fuels, when burnt, produces the heat. But this heat of the fuel does not transform into the exact work what it has to do. But in turns, it produces a metallic sound which is called as a knocking. So how we can compare or assume which fuel is best based on the knocking sound? Those fuels whose knocking is very low are assumed that best fuels. Where knocking is very high, they are assumed as lowest quality of fuel. Okay. This is the thing, like from out of all this conversation we can say that, suppose if higher octane number leads to, no, higher, if not, actually higher octane number leads to higher performance, which means it has higher compression rate. If it has a higher compression rate, the power and the efficiency of the engine is also high. Coming to next one, what is cetane number? As we discussed previously, what is diesel? So, cetane number or the CN is an indicator of the combustion speed of the diesel fuel. The higher the cetane number, the more easily the fuel will combust in the compression setting. So, out of this, I can say that increase in carbon chain length will decreases the octane number. Means suppose if carbon chain length is increases, it leads to the decrease in octane number, which leads to the decrease in performance, which means it has lower compression ratio, which means it as the engine efficiency and the power of the engine is low. And next class we'll go and we'll discuss about the gaseous nature of fuel: LPG, PNG, CNG and LNG. Thank you.